let's solve few example problems on partial fractions. All right. See the first one. You have dx by x square plus 5x plus 6. Correct. So in this, what we do, integral of dx by x square plus 5x plus 6. Right. Now, first and foremost, try to split, in the sense, try to get the factors of the denominator. That should be your first step. All right. So when we are doing that, that is means we are doing x square plus 5x plus 6. All of you know how to do splitting the middle term, right? So you can write this as x square plus 3x plus 2x plus 6, which gives us x plus 3 into x plus 2, right? So the question now becomes dx I is equal to integral of dx over x plus 3 times x plus 2, right? So by partial fraction method, what we are going to do, this is of the form a by x plus 3 plus b by x plus 2, correct? So this is the form what we are talking about. That means here I value whatever we have, the numerator, see, dx divided by x plus 3 times x plus 2, or rather than writing dx, maybe you write the coefficient, that is 1, right? A divided by x plus 3 plus b divided by x plus 2. Alright, take the LCM. You get a into x plus 2 plus b into x plus 3 divided by x plus 3 times x plus 2 is 1 by x plus 3 times x plus 2. Now the denominator is the same. So what do we get now? 1 is equal to a into x plus 2 plus b into x plus 3, correct? Now this is more like your first step of solving. Okay, now we move on to the second step. Second step is what? Choosing particular values for x so that either a gets cancelled or b gets cancelled. Okay, let me repeat it again. Now the second step is choosing some or particular values for x so that either a gets cancelled or b gets cancelled. Alright, so this is where you need to think what values do I take. But there are certain simple techniques, simple methods. I hope all of you remember zero of a polynomial, which you studied quite some time ago. Right? Zero of a polynomial meaning what? A number what you choose so that the value of the polynomial becomes 0. Now for a linear polynomial, it's very easy because just equate it to 0, get the value of x, right? We are applying the same logic here. That is, look at the equation what we have. 1 is equal to a into x plus 2 plus b into x plus 3, right? So for what value of x is x plus 2 0 minus 2? Very easy. So for what value of x is x plus 3 0 minus 3? We are going to use the same logic here. Understood? Now what do we have? We have this particular equation, right? Now for what value of x is x plus 2 0 at x is equal to negative 2? That means put x as minus 2. Now will the LHS, will it even matter for LHS? No. So 1 is equal to a into minus 2 plus 2 plus b into minus 2 plus 3. This is 0. Gone. So 1 is equal to b. See, we got the value of b. This is why we take the 0 of polynomial. In the sense, we are trying to reduce the two unknown equation into a single unknown equation. For that, we are taking the 0 of a particular polynomial. Now, we got the value of b. We got the value of b by taking the 0 of polynomial of a. that is x is equal to minus 2. Now to get rid of b, what variable do we have to take? X as minus 3, right? So now what do? We take x is equal to minus 3. So 1 is equal to a into minus 3 plus 2 plus b into minus 3 plus 3. b becomes 0. So 1 is equal to minus a is equal to minus 1. We got the value of a and b. Now things are much more easier because once you have the value of a and b, now what did we write the numerator by denominator as? What did we write this fraction as? We split it into partial fractions, correct? So I is going to become integral of minus 1 divided by x plus 3, because the a value, a by x plus 3, plus b divided by x plus 2, correct? So dx, here also dx. Now that we have dx and dx on both the sides, split the integral. There is a plus sign in between. So I is equal to minus 1 by x plus 3 plus 1 by x plus 2 dx. What is 1 by 1 plus, 1 divided by x plus 3? Log function, right? So this is going to be minus log of x plus 3 plus log of x plus 2. Right? Of course, plus c is there. Right now, I'm not writing plus c. At the end, we can write the plus c. That's not an issue. So what do you have now? Log of x plus 2 divided by x plus 3 plus c. So this is going to be the answer for the first one. So I hope all of you have understood. See, there are 3 steps in every problem. The first one is identifying what type of a partial fraction. Okay, that's the first step. Second step is once you identified, okay, this is the type of polynomial and this is the type of partial fraction what I'm going to choose. Then second is a divided by that, b divided by that, or bx plus c sometimes, depending on the problem, right? Second step, writing it in the partial fraction form. Third form, or the third step, you can say third step is the right one. Third step is integrating. So once you integrate, you will get the correct answer. Understood? So this is how we do the first one. Fine. Now, next later on, we are going to see the second one. See the second problem. So you have 2x plus 1 divided by x square plus 2 into x minus 1 dx, right? Now, which form is this? You have x square plus 2, which is a polynomial, that is a quadratic polynomial which cannot be reduced, right? That is irreducible quadratic polynomial. This is the form. When you have irreducible quadratic polynomial, we take it as ax plus b, isn't it? So now what do we have? Numerator 2x plus 1 by x square plus 2 into x minus 1. Ax plus b by x square plus 2 plus c divided by x minus 1. So whichever cannot be reduced, whichever cannot be, split, we take it as ax plus b. Since the first one cannot be, ax plus b. Second one is just a linear polynomial, so it's just c. Fair enough? Take LCM. On the LHS, take LCM. Sorry, not LHS, RHS. You have ax plus b into x minus 1 plus c into x square plus 2 by x square plus 2 into x minus 1. Correct? LHS, it's going to be the same. LHS, there is no change whatsoever. Now the denominator is going to get cancelled in both the sides. So what do we get? We get 2x plus 1 is equal to ax plus b into x minus 1 plus c into x square plus 2. So this is the second step what we have completed. Correct? So now let's do the math part. For the first part in solving, let's, you can multiply, you can compare. There is a lot of method of solving. All right, there is no one method again, I'm telling you. Multiply in the sense ax plus b into x minus 1, ax square minus ax plus bx minus b plus c into x square plus 2. Let it be. 2x plus 1 is equal to this one, correct? Now what we'll do, we'll compare. Okay, so comparison is better. So first is compare coefficients of x square. See, when you compare the coefficients of x square, LHS is 0. Do you see any x square term? No, right? So 0. Coefficient is 0. Here a plus c. Both of them may have x square term, isn't it? So what do we get? A is equal to minus c, right? After that, let's compare the constants. Yeah, so comparing constant. What constant do you see in the LHS? 1. On the RHS, see, in the RHS you see minus b. There is no x square whatsoever. So it's a constant. And then 2c, correct? So here you're going to get what? 1 is equal to minus b plus c, sorry, plus 2c, correct? Now the remaining is what? X term, all right? So when you equate, it is comparing coefficient of x. See, when you compare the coefficient of x, we get 2 is equal to, so here minus a plus b. Now if you look at it, first equation has a and c, second equation has b and c, third equation has a and b, right? We need to substitute, like take 3, reduce it to 2, and then you need to solve it, all right? So first what we'll do, look at this one. Look at this. Minus a is here. But what is minus a? Minus a is nothing but c. See, a is minus c. So minus a is equal to c, right? So what do we have? 2 is equal to c plus b, right? Look at the second equation. What do you have in the second equation? 1 is equal to 2c minus b. Comparing the coefficients of x. Add both of them. 3 is equal to 3c. So c is equal to 1. Right? Since c is equal to 1, a will be equal to negative 1. Since a is negative 1, we need to find the value of b. Right? You can keep it in the first equation or maybe the second equation. It's up to you. It's entirely up to you. But we need to find the value of b. So for b, I can substitute that in this equation. 2 is equal to minus a plus b. So 2 is equal to 1 plus b is equal to 1. Right? Now let's do the third part, that is the integration part. Now let's do the math. So what you have now? You have 2x plus 1, right? By whatever the denominator. You have ax plus b by x square plus 2 c by x minus 1. Alright. Now we got the value of a, b and c. C and b are 1 and 1 and we got a as minus 1. So minus x plus 1 by x square plus 2. Correct? So now what do we do? Look at the numerator. Split that again. That means integral of minus x by x square plus 2 plus 1 divided by x square plus 2 plus 1 by x minus 1. Now for this one, the first part, guys, take the substitution method here. Let's say x square plus 2 is t, 2x dx will be equal to dt. So maybe x dx, you guys can write it as half dt, right? So you will get this as minus integration of half dt divided by t plus this plus this. All right. Of course, everywhere you have dx, dx, dx. Okay. So and this is going to become minus half log t plus this is x square plus a square tan inverse, right? 1 by a tan inverse of x by a. So 1 by root 2 tan inverse x by root 2 plus log of x minus 1. Let's substitute back and write the final answer. What is t? We substituted x square plus 2 minus half log of x square plus 2 plus 1 by root 2 tan inverse of x by 2 plus log of x minus 1. Got it? Oh, plus c, which is very, very important, plus c. So this is the answer for the second one. Fine. Later on, as we move on, we are going to see the third one also. All right. See the third question. See here, 4x by, you have a cubic polynomial. Right. So first, let's take the cubic one. See, what we know is, first is we need to split it into its factors. Correct? Because once you split it into factors, then you know you are going to get the right answer. At least in the partial fraction form, you will be able to do it. Correct? So what we'll do? Cubic polynomial. You don't know, like directly there is no method as such. So what do? We do trial and error method. Very clearly 0 is not possible. So eliminate that. Let's start with 1. Suppose if x is 1, then you will get 1 minus 3 plus 4. So this is not 0. What if we take x as minus 1? Just in case, minus 1. Then you are going to have minus 1 whole cube is minus 1 minus 3 plus 4. Right? So we got 0. That means if x is equal to minus 1 is a root, then x plus 1 is a factor. So this is a very important part. Once you got one of the factors, do long division and get the other two. Alright. So you have x cube minus 3x square plus 4 by x plus 1. First x square times x cube plus x square. Subtract minus 4x square plus 4 minus 4x times minus 4x square. Then see minus 4x square minus 4x. So now 4x plus 4 times 4x plus 4 cancels out. So what did we get? We got it as x square minus 4x plus 4. Don't you think this is nothing but x minus 2 whole square? Correct? So we got the denominator now. Factors of this denominator we got to know. What is that? That's x minus 2 whole square into x plus 1. Correct? So let's do the math now. Let's write it down in the particular format. Alright? We have 4x by x cube minus 3x square plus 4. A divided by x minus 2 plus b divided by x minus 2 whole square plus c divided by x plus 1. Correct? So once you got this one, so what do we have? 4x is equal to a into x minus 2 into x plus 1, b into x plus 1 plus c into x minus 2 whole square. Right? Put x as 2. Then you'll get 8 is equal to, see, a gets cancelled, c gets cancelled. Right? So b into 2 plus 1, which is 3. So b is equal to 8 by 3. So we got one of the values, b is equal to 8 by 3. Now what do we do? Take x as negative 1. Take x as minus 1. So minus 4 is equal to, a gets cancelled, b also gets cancelled. C value will be c into minus 3 whole square, which is 9. So c is 9 by 4. Now what we need is a value, right? Now to get the value of a, what we'll do, we'll equate the powers, that is, not powers, we'll equate the coefficient of x square. Understood? For x square, we are going to do it. Fine? See, when you compare the coefficient of x square, 0 is equal to a plus c. Correct? Expand x minus 2 into x plus 1, expand x minus 2 whole square. You will get this. So, a is equal to minus c. But what was c? 9 by 4. So, a is equal to minus 9 by 4. Now we have all. A is minus 9 by 4 and b is 8 by 3 and c is 9 by 4. Correct? Now that you have all the three values, now let's substitute. Direct substitution and solving part. That's it. No more, no less. Fine? So, what we are going to get now, see, you will get minus 9 by 4 by x minus 2 because a value plus 8 by 3 by x minus 2 whole square plus 9 by 4 by x minus 1. Now separate integral. Integral of this, integral of this, integral of this. Correct? This is what we are going to get. Now that we have, now we need to just integrate and get the answer. Very, very simple. Fair enough? So for the first one, what you're going to get, minus 9 by 4 into log of x minus 2 plus, you can write this as x minus 2 whole power minus 2. Right? So the plus is going to become minus 8 by 3 into power minus 2 plus 1, power minus 1. So into x minus 2 whole power minus 1 plus log of x minus 1. Or final answer would be minus 9 by 4 into log of x minus 2 minus 8 by 3 into x minus 2 plus log of x minus 1 plus c. So this is going to be the final answer for the third one. Alright, guys, you don't have to memorize or you don't have to know each and every step because it comes by practice. But all I want you to know is what method to do. First one, how the partial fraction is going to come in different formats. That's the second one. So once you know these two, then you will be able to solve every type of problem. Fine. In the next video, we are going to solve problems on these partial fractions.